Greetings again everyone, welcome back to my channel. Here we have another algebraic exponential equation that we're going to solve, where we have 3 to the power of x plus x is equal to 30. And we're supposed to show all working for our solution for x. Now, as simple as this equation is, don't be deceived, it is not that easy to solve. However, just by putting in random numbers, we can already know the solution for x. Now, you might want to save this video so you can smash that like button and subscribe to my channel. You may also check out my Math Olympiad playlist to see how to solve other algebraic exponential equations. Now, our solution for this equation will come in the form of using the Lambert-W function, which is also known as the product log function. Now, you might be wondering, what is the Lambert-W function? Now, this is a unique function that helps us to solve equation where the variable is in the exponent and also in the base. And this function operates where we have a times e to the power of a, where if we apply a w function to this, the result outputs a. So our first step from here is to write our equation in the form of a times e to the power of a. So we will write our equation as that, and then we can apply our w function or our product log function. So we start by rewriting our equation as 3 to the power of x is equal to 30 minus x. So we just bring the x on the right hand side of the equation. Then from here we remove 3 to the power of x to the right hand side of the equation by dividing both sides by 3 to the power of x. And we have 3 to the power of x into 3 to the power of x gives us 1. So we will have from here we'll have 1 is equal to 30 minus x over 3 to the power of x. Now 3 to the power of x, if we look at 3 to the power of x using laws of indices, we know that where we have 1 over a, 1 over a can be rewritten as a to the power of negative 1. So if we do this to 3 to the power of x, then we can have 30 minus x being multiplied by 3 to the power of x. So from here we rewrite this as follows. So that 1 is equal to 30 minus x, we have it in bracket. Then we're just going to put that multiplication there, and then we'll have 3 to the power of negative x. Here we see we have negative x, but we also have 30, but here we only have negative x. We need to have 30 here in order to write this in the form of a times e to the power of a. And again, referring to laws of indices, we know that a to the power of m plus n, because we want to have plus 30. So that is the same as saying a to the power of m times a to the power of n. And that is how we can get the plus 30 there. So what this is saying is that we're going to have this. So that 3 to the power of 30 times 1. So we're multiplying both sides by 3 to the power of 30 is equal to negative x plus 30 times 3 to the power of negative x. And then from here now we say times again 3 to the power of 30. So we are actually multiplying both sides by 3 to the power of 30. And using our law of indices that we explained earlier, this means that we're going to have negative x plus 30. So we could rewrite that as 3 to the power of negative x plus 30. So we're just going to do that right here. So we're not 3 to the power of 30 times 1 is just going to give us 3 to the power of 30, which is equal to negative x plus 30. We have it in brackets. And then from here, we have this times 3 to the power of negative x. And then we apply our law of indices where we have the same base. So we just can simplify this as 3 to the power of x plus 30. So from here, what we have here is that we have 3 to the power of 30 is equal to negative x plus 30 in brackets times 3 to the power of negative x plus 30. Now, in order to use Lambert-W function or product log on this equation, we need to have a times e to the power of a. Now here we have a and we have a here again. These are the same. But if you look, we still don't have our e. But we can write 3 in terms of e. This is done by having e to the power of ln of 3. Let me explain. Where we have e to the power of ln of 3, you know that ln means natural log, where e is the base. So e ln of 3 can be rewritten as e log base e of 3, where we have the same base, e here and e here, the same base. This evaluates to 3. So e ln of 3, ln is going to be cancelled out by the e, and what we're going to be left with is just the 3. So all that we're essentially doing here is just writing 3 in terms of e. So we're just going to write this representation of 3 into our equation. So from here we have 3 to the power of 30 is equal to, in bracket, negative x plus 30. So we're just going to have this in bracket. And then our 3, we're just writing it in form of e. So we have e to the power of ln of 3 in brackets, because that is representing 3. And then we have this powered by negative x plus 30, because the 3 was being powered by that. So from here we have 3 to the power of 30 is equal to negative x plus 30. Again, this is going to be in bracket. And then from here we have law of indices again, where we have a to the power of m in brackets powered by n is the same as saying a to the power of m times n, or mn. So we rewrite our equation here where we have e, so that e ln of 3, and in brackets we're going to have negative x plus 30. Now if you're following closely, you will notice something interesting, where we're writing in the form of a times e to the power of a, where here should be a and here should be a. Notice now that the exponent has something different, ln of 3. We can solve our issue and write our equation in the form of a times e to the power of a by multiplying both sides by ln of 3. This means that from here we're going to have ln of 3 times 3 to the power of 30. So we're going to have that is equal to ln of 3. So this is equal to ln of 3 in bracket negative x plus 30 times e to the power of ln of 3 in brackets negative x plus 30. So notice our equation. We are writing the form of a times e to the power of a, where we have ln of 3 in brackets negative x plus 30. Here again we see ln of 3 negative x plus 30. So here is a and here is a, and we have our e in the middle. Now in applying Lambert-W function, we need to have this expression, and then we bracket this expression and add a w function. This outputs to a. So w of a times e to the power of a gives us a. So what we do is that we w this expression in our equation, and what we do on the right, we also do it on the left. So we w the left hand side and we w the right hand side. So what we have from here is that we have this w function. So we have w in brackets ln of 3 times 3 to the power of 30. And here, applying this w function on this expression a times e to the power of a, this means that we should have equals the value of a. So a is ln of 3 in brackets negative x plus 30. Now from here, we're just going to simplify our expression that we have here. So we'd have w in bracket ln of 3 times, and simplifying 3 to the power of 30 using our law of indices that we looked at earlier. So we'd have 3 to the power of 27 times 3 to the power of 3. We know this is essentially 3 to the power of 30 using the law of indices that we looked at earlier. Where we have the same base, 3 and 3, we just add the powers. 27 plus 3 gives us 30. And as we know, this is equal to ln of 3 in brackets negative x plus 30. So what we're going to do is we are going to continue to simplify this expression here. Now 3 to the power of 3 gives us 27. So taking this here, we'd have w in brackets ln of 3 times 3 to the power of 27 times, taking 3 to the power of 3 being 27, so we say times 27. And of course this is equal to ln of 3 in brackets negative x plus 30. Now from here we are just going to continue to simplify our expression that we have here. So we're going to take this 27, put it in front, and here we have 3 to the power of 27. We will write this in the form of e. We now have 3 in the form of e is e ln of 3. So we're going to have w in brackets having this 27 ln of 3. And then we rewrite 3 in terms of e. So we have this times e to the power of ln of 3. We can put that in brackets. So we have e ln of 3. And we put this in bracket because this is actually 3 raised to the power of 27. And of course, again, we have this equal to ln of 3 in brackets negative x plus 30. By now, you should guess what we are trying to achieve from here. We continue simplifying our expression by having w in brackets, so we'd have 27 ln of 3 times e to the power of 27 times ln of 3. And of course, this is equal to ln of 3 in brackets negative x plus 30. Now, if you like this video so far, don't forget to give me a thumbs up, and if you like to see more videos like these, you can subscribe to my channel. Now, as I said, it should be obvious what we're trying to achieve here. So if you look, we have a here times e raised to the power of a, which is 27 ln of 3, and we are doubling this expression. So doubling this expression means that if we apply a w to this expression, it's gonna output to the value of a. W of a times e to the power of a gives us a. So we'll just rewrite our equation using this w function. So we said that we have w in brackets 27 times ln of 3 times e to the power of 27 ln of 3 is equal to ln of 3 in brackets negative x plus 30. So having our w on this expression here, where we have 27 ln of 3 times e to the power of 27 ln of 3, this is going to output to the value of 27 ln of 3. So we have 27 ln of 3 is equal to ln of 3 in brackets negative x plus 30. So from here, we solve x by dividing both sides by ln of 3. So we divide 27 ln of 3 by ln of 3, and on the right we also divide ln of 3, which they are going to be cancelled out. So what we're going to be left with is 27 is equal to negative x plus 30. And then from here we continue to solve x by subtracting both sides by 30. So we have negative x plus 30 minus 30 and 27 minus 30. So on the right, the 30s will be cancelled out, and on the left, we're going to have 27 minus 30 gives us negative 3, and this is equal to negative x. We solve x by dividing both sides by negative 1. Having dividing both sides by negative 1, it is clear that x is therefore equal to 3. Yes, of course, we know that from the very beginning, we know that x is equal to 3. But knowing how to show our working is also essential. So using our equation, we have 3 to the power of x plus x is equal to 30. If we were to plug in 3 into our equation, so we'd have 3 to the power of 3 plus 3 is equal to 30. We know that 3 to the power of 3 gives us 27. So we'd have 27 plus 3, and we have equal 30. And we know that 27 plus 3 does equal to 30. So not only that we know that x is equal to 30, but we know to show all working that x is indeed equal to 30. Thanks again for staying tuned with me in this awesome math lesson, and I hope to see you again in the next video.